Okay, so quiz. Where is it? All right. Question number 3. Which hypothesis involves equality? And that would be the null hypothesis.
Right. Okay. Information. The p-value is the probability. Actually, hold on. Let me make this big. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true? P-value is probably obtaining sample statistic. So when I was doing the homework and watching the videos and whatnot, the p-value and like the alpha and beta, those things threw me a little bit, but I'm leaning toward thinking you'll be assuming the null hypothesis is true, right?
Yeah, I think you always assume the null hypothesis is true.
Okay. All right. So suppose the null hypothesis is mu equals 10. Which of the following represents the alternative hypothesis for a two-tailed test? So if it's a two-tailed test, that's just the one that is not equal to 10, right?
Right. Yeah, that's what I got.
Okay.
And question 6, which of the following represents the alternative hypothesis for a left-tailed test? And I got that off the video. And it's the one where we presume mu to be smaller than the population, or than the, yeah. So that would be the top one, A.
Right, yeah, mu is less than 10.
Mm-hmm.
Okay. Which of the following represents the alternative hypothesis for right-tailed? So that would be greater than 10,
Yeah,
right?
is greater than, yep.
Yeah, that's it.
Okay, remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Use this information for the next 2 questions. Which relationship would result in failing to reject the null hypothesis? So if p is greater than alpha, we fail to reject the null. So A?
Okay.
Can you guys hear me?
Yeah.
Perfect.
Hey, Flat.
Hi.
Here's your voice. All right, are you keeping up with us here? Did you already take the quiz?
Yeah, so it's kind of off of memory.
Oh, gotcha. Okay. Yeah, so
I'm trying to pull it up on my phone to see if I can go along with y'all right now to help.
Oh, gotcha. Yeah, and I have trouble. I'm looking at the quiz, so I'm not looking at the actual Hangout page. So, anyways, all right. Okay, so 8 is done. We're on to 9. Which relationship would result in rejecting the null hypothesis? So that's the opposite. So that's when the p-value is smaller than alpha.
All right. And just moving along, the information. An insurance company is reviewing its policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They're concerned that the true mean is actually higher than this now. Which of the following would be appropriate alternative hypotheses? So, if they're concerned that it is now higher, it would be the average claim amount is greater than 1,500, right?
Let's see.
Yep. Yep.
Okay, question 11 says, which of the following would be the appropriate null hypothesis? A, the average claim amount is equal to 1,500. B, the average claim amount is not equal to 1,500. C, the average claim amount is greater than 1,500. Or D, the average claim amount is less than 1,500. So your null hypothesis has to be equality, so that would be A.
Yeah, should be equal.
Alright. The insurance company randomly selects a sample size of 40 people or 40 claims and calculates the sample mean to be $1,650. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? So, because n is greater than 30, that would make it normal?
Yeah, that the sample size is large.
Mm-hmm.
Yeah, that's what I got. And so what theorem or law justifies your answer? The law of large numbers, the central limit theorem, or the law of total probability? Have we talked about the law of total probability?
I don't think so yet.
Okay.
I recognize.
I wasn't familiar with it. So I picked the CLT.
Yeah.
Sounds good to me.
All right, question 14. Which of the following is the test statistic as defined in this lesson? And this is the one I missed before. So X bar, Z, S, or N? And I had picked X bar, but I got it wrong. So
It's usually Z.
it's Z. Yeah, because it's the Z score, right?
Yep.
Yeah.
It's just looking for it for the sample mean.
Right. All right. The historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects the average has decreased. She sets up a hypothesis test with the null hypothesis mean equaling 150, and the alternative hypothesis is less than 150. She will use a level of significance of alpha at equals 0.05, and then she then takes a simple random sample of 36 sales receipts from her store and computes X bar at 144. So use this information to answer the next 4 questions. What is the Z-score associated with this test? So it is where did I write that down? So it's 144 minus 150
Over the
divided by
Well, you didn't. I think you didn't even pay Marley that.
40 divided by the square root of 36.
Divided by the square root. So divided by the square root of
36.
36.
Mm-hmm.
So I got -1. That sound right?
I got -0.9.
That's what I think I got. Negative 0.900.
Okay.
So, do you want to talk about how you got 1? Or do you see how we got? That was part of my question on one of that part 2 on our assignments. I got a different answer and I couldn't figure out how they got the answer they did. But anyways, it was close. I ended up getting other answers that were similar down the road, but
I assume I'm pretty sure I probably messed up in my calculations because I'm pretty sure I know how to do that. Like it's the same formula, right? Or similar at least.
It sounds like you just rounded.
Maybe I did. But yeah, I'm not worried about it. But I'm pretty sure you guys are probably right with the
okay.
way you were
Okay.
pointing out.
So then the next one says, what is the p-value associated with the z-score? So we go into the normal probability applet and put on our z-score of -0.9 and highlight to the left of that, and I get 0.184.
Yep.
All right. Looks good.
And then, what inference would you make about the null hypothesis for this problem? Reject it or fail to reject it? So, if P is, in this instance, P is larger than alpha, so we fail to reject the null hypothesis.
Okay, question 18. What is your conclusion for this problem? So we just failed to reject the null hypothesis. So that means the null hypothesis is true.
Right.
So I'm looking at the second one.
So we either have sufficient evidence that the true population mean is 150, or we have insufficient evidence that the true population mean is less than 150. So we're not, I put the third one because we didn't try to prove the null hypothesis to be true. And that's kind of what the second one, that's how I read the second one. That, yes, we've proved that it's 150.
Oh.
Haven't done that. We've just
Yeah, you're
proved
right.
that we don't have enough evidence to say it's not that. So
Right.
Yeah, you're right. That makes sense.
okay, question 19. There are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? Type 1 or type 2? And that is a
Type 1.
Type 1.
Yep.
Okay, question 20. The researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. So which of the following will be true? The probability of a type 1 error will increase. The probability of a type 2 error will increase. The probability that the null hypothesis is true will decrease. Or his experiment will be more scientifically valid. Okay, so if A gets smaller,
Type 1.
then beta gets bigger. So the probability of a type 2 will increase.
Yep.
Is that right?
I agree. If A equals 0.05, compute the probability of committing a type 1 error.
So I put 0.05
That's what I
because
thought.
that is the probability. Yeah. That's what alpha stands for, is the probability.
Mm-hmm.
Okay.
All right, let's
So.
see how we did. Sweet, 100%.
Yep. Okay.
All right.
Alrighty.
Thank you very much, guys.
Yeah, that was
Yeah,
good.
thank you. Have a good day. Okay.
Yeah, we'll
Bye.
see you next
All
time.
right, see you guys.
So Tuesday at 12?
Noon. Yeah.
Something like that? Okay.
Yeah.
Okay. All right.
Okay.
See you then.
Sounds
Okay, see ya.
Bye.